not actually divided a number in a really long time without a calculator. So just to kind of walk you through that process, because a lot of this is going to look the same once we start getting to the polynomial part. So looking at number 1, when you're dividing, you're looking at the divisor, the outside number, and you're seeing how many times it goes inside the dividend. Now, if you remember this and you know how to do it, wonderful. Some of us may not, so just going basic baby steps first. So does 16 go into 4? No. So anytime it doesn't fit into the number, you move to the next one. So does 16 go into 40? How many times? Twice. So I'm going to write a 2 up here. Now, one thing that I'm going to point out, because this is going to be the tie-in to polynomial division, is we're going to take 2 and we're going to multiply it by 16. And that's going to be important when we do the polynomial. And we write it underneath. And so one thing that we do after we figured out what that multiple is we go in and we subtract. These 2 steps that we just did, the multiplication and the subtraction, is exactly the same steps we're going to use for polynomials. So what is 40 minus 32? 8. Now, if you get to a point where your divisor does not fit into your number, because now we're not focused on 4,048, we're focused on just 8. If it doesn't fit in there, you always bring a number down. So 16 does go into 84. It goes into 84 5 times, just to make our lives a little bit easier. 5 times 16 is 80. We multiply, we subtract. And that is the process for polynomial division. We're going to look at our divisor. We're going to look at our dividend. We're going to see what multiplies, what fits inside of the divisor. We're going to multiply. We're going to subtract. Exact same steps. It's just not numbers. It's going to be x terms for the most part. Now, does 16 go into 48? How many times? 3. 253, 48, we subtract. In an ideal perfect world, this last number would be 0. That is our remainder. Now, all of this kind of ties in together for the polynomial part. So if you know these basic steps for numbers, the steps for polynomial long division work exactly the same. Now, one thing, yeah, Max.
What do you do with a remainder
If it's not 0, you would just, in numbers, you just write remainder 2 or something like that. For us in polynomial, we're just going to write it over the divisor, because technically we could say remainder 0 over 16. But if I had like a 2 as my remainder, I'd write 2 over 16 and simplify. It's going to kind of tie in that way. One thing you should always check for, and I think I tried to, in the formative, make a note on some of these. You want to make sure when you're doing these long division problems, and even synthetic, that you don't have any missing terms. So when you go in and you look at your divisor and your dividend, if it's missing terms at the very front, that's completely fine. You don't have to add in extra terms there, but you want to make sure that you are counting down. So technically, this is x to the 1 and this is x to the 0, which is 1, a constant. If you're missing any terms in the middle of your beginning term and your end term, you have to fill them in with a 0. Otherwise, like with the number division, if your lines, like if you don't line up your numbers nicely, it's going to start getting confusing. So we want to make sure that everything lines up nicely. The way to do that is to make sure that if you have missing terms, you're filling in those blanks. Otherwise, life gets complicated. So let's go in. Let's try it out. I promise it looks harder than it actually is. As long as you know how to divide numbers, you should hopefully get this fairly easy. So what we're going to do is we're going to focus only on the first terms. That's all we care about for now. Because again, when you're doing it with numbers, you only care about the first numbers. So if I have x squared and I have to find something that I'm going to multiply x squared by to make x cubed, what would it be? 1 or x? X, because what's x squared times x? X cubed. So what I'm going to do is up here, I'm going to put an x. So same exact thought process as when I had, what was my number? 40, and I had 16. 2 times 16 made 32. That's the biggest number I can fit inside of 40. I made x times x squared is going to give me x cubed. Are we all with me so far? It is division, it's not multiplication. We're getting to the multiplication part. Hold on. Now, one thing about whenever you're picking these numbers, the divisor, the entire divisor matters. So yes, I came in and I was trying to figure out x times x squared gives me x cubed, but you have to think about the fact that there are other terms at play. So whenever I take this x and I multiply it, it's going to get multiplied by every single term of the divisor. So what's x times 4x? 4x squared. So I'm going to write plus 4x squared. What's x times negative 2? Negative 2x. So I'm going to write negative 2x. So think back to our number problem. We said we're going to multiply, then we're going to subtract. We've done the multiply part. Now we're going to go and subtract. This is the part that a lot of people will mess up because they don't pay attention to signs. I'm taking this entire thing and I make big subtractions in parentheses. Everything that I just multiplied is being subtracted from what's directly above it. So ideally, you should end up with that first term going away. Because what's x cubed minus x cubed? 0. So that should end up canceling out. What's 7x squared? And it's not adding 4x squared. That is being subtracted. What's 7x squared minus 4x squared? 3x squared. So I'm going to have 3. You technically don't really have to write the 0, but I'm writing it for the sake of understanding. And what happens, well, before I get there, what happens when I subtract a negative number? It gets bigger. It becomes a positive. 2 negatives make a positive. So instead of this being 10 minus 2x, it's actually 10 plus 2x because I am subtracting a negative number. So what's 10x plus 2x? 12x. 12x. Now, what I like to do, just because these do get to be longer, anything that follows after this step, because we're done with like the first round of doing this, I bring down whatever is left over. So I'm just going to bring down this minus 6. Now, second round of this, I'm going to go in, and this is kind of like we're at the point where we got 8, we dropped the 4, and we're trying to see how many times does 16 go into 84. We're on that second round. I'm not looking at the 0 because the 0 is not going to matter. I'm focused on the 3x squared. That's the next term that I have. And I'm still looking at x squared. What do I have to multiply x squared by to make 3x squared? Do I need an x? I just need a 3, right? Because I already have x squared from the term. I need it to be 3x squared, so I need to be multiplying by 3. So I'm going to go in and I'm going to say plus 3. The reason why it's plus 3 is because I need it to be a positive 3, not a negative 3. We want it to be the same number because when I go in and subtract, that's what's going to cancel it out. Same exact steps. I'm going to take 3. I'm going to multiply it by every single term. So I'm going to have 3x squared plus 12x minus 6. So we did the multiplication. Now we go in, and again, I make this like very bold, very big, so I don't forget that I'm subtracting. Most of the time, it's not going to be a big problem. It's going to run into issues when you have those double negatives, and people forget that they need to add. So 3x squared minus 3x squared is 0. What's 12x minus 12x? 0. Okay. What's negative 6 minus negative 6? 0. So do I have anything left over? No. So my remainder is 0. Now that doesn't necessarily matter. If you just ended it at 0, that would be fine. Our answer, we're done. This problem is done, is just going to be whatever we ended up with up here. This is our quotient. That is a factor of the dividend, so the number that's inside, that is a factor. If I take what I just got, x plus 3, and I multiplied it by x squared plus 4x minus 2, I will get the dividend inside the dividing problem. Yes?
Confused on how you got the x from the x squared and x cubed.
Well, x times x squared is x cubed. So I had to pick something where if I multiplied x squared by it, it would make x cubed. In the same way, I was trying to make 3x squared. I have an x squared. I want to make 3x squared, so I multiplied by 3. So it's just what do I need to add in to make it so that these numbers multiply to be these values? Yes? So they do play a part in taking away from the other terms. It's just whenever you're picking that first term, we're trying to eliminate the first term only. That's why we only care about that first. It falls in line later on. It's just we only want to eliminate the first term as we move from step to step to step. Okay, we will try this again. We will do this a couple more times together, and then we'll have time to practice on your own. So let's do another one. Let's look at number 3. Now, the one thing that I'm going to point out for number 3 is we have 4x squared plus 16. And one of the things I said you have to check is that you check that there are no missing terms. You should be going from exponent 3, 2, 1, 0. In this case, we're starting with an exponent of 2. So the next term that I should see has an exponent of 1. In this case, I don't have that term. So what I'm going to actually do before I start anything else, I'm going to fill in those missing terms. So you don't have to fill in anything in the beginning, but if there's something missing in the middle, so I'm missing the x to the 1, just the x term, you want to fill in a 0 for whatever that is. In this case, since it's x to the 1, it's 0x. And then I have plus 16. In the bottom, I'm going from an x to the 1 to an x to the 0, so I'm not missing anything. So I'm just going to leave that alone. Now, again, I know in the example it says x to the 5, x to the 4, x to the 3. You don't have to add in any terms at the beginning. It's just if you're missing any terms in the middle, to make things line up nicely, you want to put zeros there. It's not required, but then I can promise you things start to shift and you subtract the wrong things from the wrong things. So let's write this out. I'm going to put my divisor, 2x minus 2. I'm going to put my dividend, 4x squared plus 0x plus 16. The goal is to get rid of the first terms as we go from step to step. So the only thing I care about right now, if my goal is to eliminate the first term, the 4x squared, I only care about the 2x and the 4x squared. So you're asking yourself the question, what do I have to multiply 2x by to make 4x squared? 2x. So I'm going to write 2x on the top because that's what I need. 2x times 2x is 4x squared. So same exact steps, multiply then subtract. So I'm going to take my 2x, I'm going to multiply it by both terms of the divisor, 4x squared minus 4x, and then I'm going to remember that I am subtracting. Really, you want to be careful because of those double negatives, because you don't want to accidentally subtract when you should have added, because 2 negatives make a positive. Now, first term should ideally always cancel. If you find that that first term is not canceling, either you picked the wrong number at the top or you multiplied incorrectly, but it should cancel out. So this 4x squared minus 4x squared, those are going to kind of just go away. They cancel out. That's the goal. Then I'm going in and I have 0x minus negative 4x. 2 negatives make a positive. So if I combine those two things together, I get positive 4x. And just to keep things organized, I will always suggest just drop the next thing. You can drop all of the terms if you really want to. I probably will, just because it keeps things neat. Now, second goal. I've eliminated the first term. Now I want to focus on this 4x. And I'm still working with 2x because that's the only term I can use to get rid of 4x, but they need to be the same number. So what do I multiply 2x by to make 4x? 2. So whatever number you pick, if it's positive or negative, you use that sign. So we said positive 2. So I'm going to go in and I'm going to write plus 2. And so I'm going to do the same exact steps. I'm going to take the 2 that I just said and multiply the divisor. That's going to be 4x minus 4. So we did the multiplication. Now we are going to subtract. The first term should always cancel out. It should always go away. If it's not canceling out, you are either picking the wrong number or you are not multiplying correctly. The goal is for it to be gone. 16 minus negative 4 is going to turn into 16 plus 4, which is 20. Now, can I do anything that is not fractions, because we can't use fractions? We can kind of, but not really. Is there anything I can do with 2x to turn it into 20? Yes, Wyatt. What's a negative negative? Subtracting a negative number turns into a positive. Okay. So is there anything I can do with 2x that turns it into 20? No? No, right? 2x into 20. No. So if you cannot do anything, there's nothing else you can do with your divisor and the number you are looking at, that is it. You're done. This number is going to be our remainder. Now, the one thing about a remainder is, I'm going to make a little note, must be written as a fraction over the divisor. So by that, I mean, we are going to take our 2x plus 2, because that's a big part of what we have. And so we're going to take the 2x plus 2, but we're also going to take into account that we have a remainder. So we're going to take that remainder. It's going to be written as a fraction. The bottom part of the fraction is going to be your divisor. Now remember, the divisor is the outside number or polynomial. So in this case, 2x minus 2. So whenever you write this, and yes, as part of the final scoring for a question like this on your test, if you get a remainder, it has to be written this way. There is no other option if you want full credit on a question like this. It has to be written over the divisor. So sometimes it's a positive number and you'll write it with a plus sign. Sometimes it's a negative number, you'll write it with a minus sign. It just depends on what remainder you get in the end. Do I have any questions so far? Okay, let's try it again. Back to the back page. There's only 2 more. We have our polynomial long division. The first thing I always do is I go in and I look and I try to see, okay, am I missing any terms in the dividend? I have 3, 2, 1 constant, so I'm not missing anything there. But when I look at the divisor, I see that it jumps from x squared to a constant value. It should always go from x squared to x to constant. So in those cases, when I write out my divisor, x squared plus, I'm going to place a middle term. I'm going to place 0x. The same way I did in example 3, you don't want things where they don't line up nicely. So then I'm going to come in. And for these, if you have the I know that I can line them up good and I'm not going to worry about missing terms, you don't necessarily need the 0 term, but you have to remember when you start doing this multiplication that the squareds need to line up, the cubes need to line up, the x's need to line up, and the constants need to line up. Otherwise, things get a little weird. So let's start this one off. Same way we've been doing. X squared, x cubed. What do I have to multiply x squared by to make x cubed? X. So I'm going to write an x at the top. That x is going to distribute to every term of my divisor. So I'm going to have x cubed plus 0x squared plus 2x. So all I did was take this x and multiply all parts of my divisor. So multiply, subtract. Now I'm going to go in. I'm going to subtract from the term above. And remember, that first term should always cancel. It should always go away because that's the whole point of us trying to figure out what multiplies to make the terms in your dividend. What is 5x squared minus 0x squared? 5x squared, wonderful. What is 2x minus 2x? 0x. I'm going to just write 0x just to keep things in line. I'm going to bring down this minus 2. One common mistake we see on the test. If you're not bringing these terms down constantly, some people will forget that they didn't bring something down and they'll stop when they have other steps they could do. So that's why I like to bring them down every single time I run through one of these steps for multiplying and subtracting. Okay, now let's look at x squared and let's look at 5x squared. What do I have to multiply x squared by to make 5x squared? 5. Positive 5 or negative 5? Positive 5. So I'm going to write plus 5. And then that 5 is going to distribute to every single thing. 5x squared plus 0x plus 10. And then I am subtracting, again, very bold so I don't forget that I am subtracting. First term should always cancel. 0x minus 0x is also going to cancel. What is negative 2 minus 10? Negative 12. So this negative 12 is actually going to end up being my remainder, but bless you, we have to go in and write it as a fraction as a part of my final answer. So I'm going to have from my multiplying, I have x plus 5. Now you have two ways you can write this. Because it's negative, I usually just say minus 12 over x squared plus 2 because that's my divisor. But you also, we accept x plus 5 plus negative 12 over x squared plus 2. I don't care which one you do. If you want to keep the 0 term as a part of your divisor, that is also completely fine. I just didn't want to write it out. Yes, Ite. I just said that. That is completely fine. So if you wrote x squared plus 0x plus 2 at the bottom, also okay. So the one thing I will make sure that you do not forget, if it's a negative, there has to be a negative sign somewhere there. Don't do a negative and a negative because technically that's a positive, but either in subtraction or adding a negative. We'll take either one. Any questions on this one? Okay, last one. I think this one ends up with a slightly different remainder, so I wanted you to at least see one like this. We have 4, 3, let me go in and check. 4, 3, 2, 1 constant, 2, 1 constant. We're not missing anything, which is nice. I need to look at x squared, and I need to look at x to the 4th. And so what you're asking yourself, just to kind of bring this back into what we're doing, if I wanted to make x to the 4th, what do I have to multiply x squared by?
X to the second.
X to the 2nd. So one of the exponent rules that we have is if you are trying to make something through multiplication, you need to ask yourself, what am I adding to that? So in this case, if I wanted to make x to the 4 and I have x to the 2, I need another x to the 2. So I'm going to write x squared. Same exact steps, that x squared is going to multiply, multiply, multiply. So I'm going to have x to the 4th plus x to the 3rd plus 2x squared. And then we're going in and we are subtracting from the row or the line above us. I, again, cannot stress enough that you need to remember you are subtracting, just because that's one of the common mistakes that we see. First term should always cancel. X fourth goes away. I have 2x cubed minus x cubed. So how many x cubes am I left with? 1x cubed. So I'm just going to write x cubed. I'll keep my... And then I have negative 3x squared minus 2x squared. So what's negative 3 minus 2? Negative 5x squared. I personally, again, as something I can suggest, if you have anything left over, bring it down. You don't want to forget that there are terms in the dividend that you forgot about. You don't want that to happen. So I just bring everything down. I know in number division, you don't always do that. In polynomial, it just makes things a little bit nicer in terms of lining up. So now I have a x squared, and I want to make x cubed. What do I have to multiply x squared by? An x. So I'm going to have plus x. You want to pay attention to the signs because that's going to tell you whether it's positive or negative. So I'm going to go through the steps again. X cubed plus x squared plus 2x. So all I did was take my x term and I distributed it to all 3 terms of my divisor. And then we come in and we subtract. You are promised doing the same steps over and over and over again. There's not really that much in these questions that's going to switch up at all. You're doing the same exact steps. So we're going to go in. We are going to subtract negative 5x squared minus x squared. So what's negative 5 minus 1? Negative 6x squared. Now, like I have mentioned before in terms of the number sets, none of the numbers that we will give you for this are like insanely large. But you have to make sure that you understand how to combine negative numbers, how to subtract from a negative, how to add to a negative, that 2 negatives make a positive, because if those are things that you're struggling with, that makes this entire process a lot harder. So make sure that you feel comfortable with the adding of the numbers and subtracting of the numbers. And then I have 4 minus 2, so that's going to be plus 2x. And I will always suggest if there is something that has not been dealt with yet, bring it all the way down. So I'm just going to bring that plus 4 down. Now this is one where we're going to have to go one more time. So I'm going to look at the negative 6x squared, and I have an x squared already. So what do I have to multiply x squared by to make negative 6x? Negative 6. So I'm going to go in, negative 6, and the same exact steps, multiply, subtract. So I'm going to have negative 6x squared minus 6x minus 12. Now this one I would suggest being very careful on because they're all negative numbers. So technically when I subtract, they're all going to turn into addition because 2 negatives make a positive. So negative 6x squared plus 6x squared cancels, and that should happen every single time. That first term should go away. And then I have 2x plus 6x. So what's 2x plus 6x? 8x. And then I have 4 plus 12, which is 16? 16. Okay, so I ended, I'm going to make this blue just for my color coding. I ended with 8x plus 16. Can I do anything? And this is very rhetorical. There's not going to be a right answer, a correct answer. Well, there's not going to be an answer. Can I multiply anything by x squared to make 8x? No. If you get to a point where you cannot do anything else, like the exponent of the divisor is bigger than the exponent of your current, where you're at, you can't do anything. So that means that where we're at, that 8x plus 16, that is going to be my remainder. Now, how you write this, it's exactly the same way as if it was just a number. I'm going to take x squared plus x minus 6, and then all I'm going to do is take my remainder, 8x plus 16, and I'm going to divide it by the divisor. So x squared plus x plus 2. And this will end up being my final answer. So when you get to a point where there's nothing else that you can do, it is mostly if your exponent is less than the divisor, you're done. That is your remainder. Write it as a fraction. You're done with your division. Do I have any questions? I'm going to come around. You have 4 problems for practice today. This practice will be due next class period, so make sure that you are working on it. We have one more lesson, 4.4, and then review day, test day. Your test is next Wednesday.